for the EV fleet operators like Bounce or Velo or On Bikes, these are the EV fleet operators. So we give the support for the technology for them. And if one requires the sourcing support, so that's what also we provide. Training is our heart, and training we provide for the manpower in the lithium-ion batteries, EV powertrain, smart electronics, everything. And internships are there if you're a student. So then we have the job support, trainings, and the internships opportunity for you. So integrated services that we provide towards the training, development, and the consultancy. That's what it is. So few of the projects which we have, like this is the IoT based powertrain. Maybe you have seen it on our YouTube channel. So here is a powertrain, EV powertrain, which is controlled by the voice and through means of IoT. Here everything is developed by us, and it is there for some OEM who is taking this solution and deployed their products. So this is for the 36 volt powertrain that is on display.
So you have heard that the bike is getting unlocked, and you can also see my bike is unlocked. Now I need to ride it. So I just give the throttle, but you see that I am not able to ride it yet because I have not been authorized. So I am authorizing my bike to give me a ride. So okay Google, turn bike on. Turning bike on. Oh, so my bike is on now. Now I will ride. So you can see I'm riding my bike, giving the throttles, I'm riding my bike, I'm riding, and my brakes is applied. We have the motor controller, we have IoT.
If you are developing the battery pack or whether it is your electric vehicle application, so it is not just about the providing the motor running, or it is the arrangement of the components into your vehicle, or maybe the arrangement of the raw materials for the battery pack into your complete battery pack. Actually, there is a more beyond, and that requires the authentication, that requires the security provisions, that requires that the right person is using your vehicle or right person is using your battery pack. The right battery pack is matched with the right vehicle. So all these kind of requirements now getting developed now. And if it is a swapping environment, like you have seen the policies of the government that now the battery business and vehicle business could be separate. So then there is a requirement for establishing a complete infrastructure, and the people are towards that, where we have the complete battery business model, a separate battery business model, where from the starting from the packing of the batteries to the deployment level and authenticated and working everything in the secured environment. So those all things are required. So there is this technology enhancements and enablement is required apart from the towards the electronics side, also apart from the lithium-ion batteries design and development. So it is the complete integration. So if I'm talking about the lithium-ion batteries, so it is not just the battery, or it is not just about the estimations, but it is the complete of both of the things: the knowledge on the battery pack side, the knowledge on the powertrain side, and knowledge on the electronic side. Everything is required once you are into this field, and then you can excel into. So that's what a small introduction that I was giving you. Some of the vehicles which has been designed by some students are doing the development of the vehicles and the battery, you can see. So these are the few things. So this is the spot welding that has been done. So this is the before lockdown. After lockdown, this scene is a rare that most of the things are online now. But so this is a manual spot welding, as you can see on the left hand side, and then we have this automatic. So this was the semi-automated welding machine, spot welding machine. So these all are the things which is used, and this is used in the assembly and in the semi portable or in a complete portable, or maybe in a semi-established environment for the manufacturing of the things. What our agenda today is to talk you about the lithium-ion technology, and specifically that what is driving the lithium-ion technology in today's world, what potential we have and where is the growth potential, because it is divided into world is divided into zones. And once we are talking about the lithium ion, so for each and every zone there is a difference in the policies are there, and then there is a separate growth potential is there. In some of the zones we have the high availability of the raw materials, whereas in the other part of the world we have the consumption. So we need to look at that where the consumption is, and in the part of the world where we are, is the right place for the consumption, or where we should look at the other market. So that's what also we will be seeing the growth potential. Then specifically the lips in EV, because specifically if we talk in terms of India, so majority of the consumption of the lithium ions are there in the electric vehicles right now, because towards the manufacturer side, if I'm talking about, the consumption is there in the mobiles, but we are not making manufacturing or making the battery packs for the mobiles as of now, because we are not making the mobiles here. The most of the things are getting sourced from out of the country, and there are the few of the operators are there who is doing this thing. So if largely, if in a retail environment, if I talk about the manufacturing side or the technology that is getting developed for the lithium ions, it is towards the electric vehicle applications. So we will see that what it is required in the EV for the electric vehicles, the lithium ion. Then smart electronics, what it is required and what is the innovation potentials, and then what is the opportunity that you have in this domain, and what are the skills that you require to excel in this domain. So these all are the agenda today, which we are going to discuss. So first come first, that lithium ion batteries in industrial applications and what drives it, and who is the main competitor of the lithium ion battery in this domain is, it is the lead acid. So there is a harsh competition between the lead acid and the lithium ion. And definitely the lithium ion is leading the way, because it has the few of good potentials available in comparison to the lead acid. And that not only in terms of the weight or the power capabilities, but also it can do larger of the vibrations and the shocks, everything. So for the mobility applications, what we require that it should be able to tolerate all these kind of mechanical problems. So this thing is driving the lithium ion to be used in the EV. It is maintenance free as such, means the majority of the maintenance that you don't require in the lithium ion. The runtime is higher because we have the higher energy density in the lithium ion compared to the lead acids, and life cycle is quite high. So the discard of battery is after a longer amount of a time compared to your lead acids. So all these are the positive factors that you have in case of your lithium ion which you are using, and that's why it has been used not only in the electric vehicles but other, which we are going to discuss also in other of the domains also. But there are certain shortcomings are there, that one-time cost is really still high, though the work is there, and to bring the cost lower, and it is getting drastically, the cost is also getting drastically lower. But until and unless we don't have our own manufacturing lines, and that we don't see this year, maybe by the end of this year or next year start, we will have some self manufacturing starting. The sample pieces are getting ready, and then maybe in 2 to 3 years we will have some plants running in a full capacity. Then we will have the cells over here also, and can be the cost could be brought more lower. Then the possibility of thermal runaway. So it is a very sensitive compared to your lead acid. So I say that the lithium ion is as sensitive as a human is. The temperature conditions in which you are working and you feel efficient, the same temperature conditions the lithium ion has. So that's why if you are not able to manage about the temperature, so there is a very high possibility of having the thermal runaway, and BMS is required. So electronics is required, and until and unless you don't have the smart electronics around your lithium ion, you cannot use the full potential of it, and there is a high chance of battery getting decayed very fast. So these are the shortcomings that we have, but still there are the lots of positive sides of using the lithium ion, and that's why it is getting used in the most of the industries. And this only not limited to the electric vehicles. So you can see that starting from your notebook mobile applications to the solar, thereafter to the buses, mobility applications, the watch, the power tools, the drones, thereafter vehicles, So single or dual wheeled vehicles to the multi-wheeled vehicles. Everywhere there is a requirement, and there is a huge potential of around 638 gigawatt hour of a requirement is expected in the next 2 to 3 years. And it is not only the uplift of the electric vehicles that is driving the use of lithium ion, but also apart from that, there is a huge growth in the consumer electronics domain. So consumer electronics domain and the IoT domain. So you know that in the IoT, lots and lots of type of sensors are getting used, and all those sensors are wireless. And those sensors are also having the lithium ion itself, so that it can be powered. So, but in context of India, if I'm talking about that, we are not manufacturing sensors as of now. Those IoT sensors are not getting manufactured in a bulk quantity as of now. And so then we have a less potential towards that currently, but we have a higher potential into the mobility application, into the solar applications, and the work is started, and then the UAV applications, we have a huge potential. UAVs are being done over here. And then we have some potentials into the mobile and the power bank side. So these are our Nikkei areas where there is a lot of work is going on, and we should look towards our opportunities into this. So there is a very high a growing demand for application segment for the lithium ions, and then there is a new battery applications are coming up. So nowadays there is a more and more requirement towards the secondary power sources compared to the completely connected power environment, because we are in an age where we require the mobile electronics, the portable electronics that we require. And if we are talking about the portable electronics, it is the lithium ion that is driving it. So that's why it is very true to say that we are in the right edge, and now the time is started. Actually, we are running behind that there is a huge potential for the lithium ion is there into this. So if zone wise, if I have to say, so 3 zones, that is the major. It is the North American zone, the European zone, and the APAC market, our own. So Asia Pacific. And if you see, so there is a total of the 90% of the consumption of the batteries are going in these 3 zones. And in this, it is growing at a CAGR of 15.4%. And right now, means 2019, it was around 40 billions. And in next 2 years, it is expected, next 2 to 3 years, it is expected to be more than 76 billion, and it is crossing around 100 billion. So total data, if you see, so it is crossing around 100 billions of US dollars. And the growth potential, if you see, so here is the segmentation wise growth potential. And if you can see that the majority of the growth, which is projected, which is there, in the 2021 we are, and then it is the projection. So if you can see, majority of the growth is there in the APAC region where we are, the India, China, and all these places. And right now, the government's main focus, as per the policy of government, so by 2030, the complete policy that what they have laid out. So right now, the years in which we are, there is a high focus of governments towards the battery pack manufacturing side. And that will last up to next 2 to 3 years. And thereafter, the government's focus will shift towards the cell manufacturing side. So then once it will be the cell manufacturing will be there in the Indian zone, then this majority of this gray region will be in the Indian zone itself. So that's why it is the high potential, and we are in the high. We will be the high consumption, high production domain also, and we are having the high consumptions also. So hand to hand to the China, and we are not. In the technology, we are not far behind to China also. So if you are talking about the technologies uses, so we are going hand in hand into as per the rest of the world. And then we have the market in the EU. So EU is also very nearby, and you can explore lots of opportunity in the EU domain. And fortunately, the policies are mostly same. Like if I'm talking about the Canadian and the American zones, so policies are quite different from here. And there are a lot more of hard trust patterns that we have. But comparatively, the similar of policies that is being followed in the EU and the APAC domains. So there is a lot of opportunity into this domain, and there is a high rise potential is also. That's what. Apart from that, if you see the domain wise, so highest is in the towards the consumer electronics, which I was talking about, and the automotive side. So we are in the automotive sectors right now, majorly the automotive sector's batteries that we are talking about, and there is a high consumption potential is there. But once we were able to tap about the consumer electronics, then around more than 50% of the consumption of the market that we will be covering with the lithium ion. So this is the growth potential, and definitely with the support that what the data that we are able to see. So it is by the practical experiences and by the data which is a supporting data. So we are in the right domain, we are in the right zone, and we are in the right time so that we can be working in this domain and can conquer this industry. So specifically, if the lithium and specifically in the electric vehicles applications, if I'm talking about, so what is the battery chemistries that you see most? It is actually it started. So EV is not a new thing, though we have started seeing the EVs again in recently 5-6 years back. But initially it was the EV, then came the petrol engine vehicles, and then again 100 years of the petrol engine vehicles were there, petrol and diesel engine vehicles were there, and then again we are shifting towards the EV, and EV will be having a major cut in the industry. So in the automotive domain. So initially it was started with the lead acid, but now the completely market is shifted towards the lithium ion almost, and very few of vehicles are using the lead acid, and then of what it is more shifting towards. So lithium air is a one battery chemistry which is under development, and almost testings have been performed over it. And as per the hype curve, so there is a hype curve of the batteries are maintained. So any of the chemistry that gets introduced, there is a lot of talk that starts happening about the chemistry. So it goes on the hype of it. And then once it is on the top of hype, then the practical applications and the practical testing of the batteries, the cell chemistry starts. Then whether it succeeds or not. So after the hype, then it is the behavior of that chemistry, that whether it will be satisfying to the needs of the people or the needs of the application or not. Based on this, either it will fall down if it is not satisfying, or from here it will rise again. So lithium ion is right now on this stage that it is rising because it is satisfying the needs of the application after the hype. And in this curve also, so lithium air is also on the same curve. So it is expected that after the lithium ion, so the lithium air would be the next of the thing. But if you will go through the YouTube or maybe the articles, if you are reading, so maybe every week you must be hearing of some new chemistries, but every chemistry is not going to establish, and every chemistry is not going to satisfy the needs of your electric vehicles or solar applications. So there are the certains of chemistries which would be used, and they are going to stay. So even if the lithium air comes, it is not of a worry. So because if you are proficient into the lithium ion domain, so you can easily handle the lithium air in place of the graphite. So air would be used into that, and it would be a very the weight will be very less of these batteries, and handling will be quite easy for the lithium air. But it is still in the applications, it is still expected to be more than 10 years it will take to come into the applications. So this is how it is moving. And why there is a choose? So from the lead acid, the choice is towards the lithium-based cells. Why? Because we need the higher of the specific energies and higher of the specific capacities from the battery. So whatever we are calculating, there is always a theoretical capacity, and then whatever the energy that we get out of it, that's the practical specific energy. So compared to all of the other cell chemistries, if you see, the lithium ion is having the higher of practical specific energy. So you can see over here compared to the lead acid, NiCad, and the others. So we have the higher of lithium, higher of the practical specific energy. So that's why it is as per the volume and as per the mass. So as per the volume, it is smaller in the size, and as per mass, it is also lighter. So that's what the two things that is required, that in smaller of the size and smaller of the weight, we are having the higher of energy stored. So which is a very, very good for my portable applications. And that's why the lithium ion is the first choice now. And once it will be the lithium air, so then we will have more specific energy. So that's what it is expected. So, and then we have lithium ion, which is having the higher of life cycle also. So why this high life cycle we have in the lithium ion? Because in the lead acid, the metals are there and they are taking part into the reaction, and then they are getting decayed. But specifically in case of a lithium ion, if you see the reaction, the chemical compounds and the reaction that is going to happen. So it is the lightest metal available, and lithium doesn't take part directly in the reaction. So it is the lithium cobalt oxide is there, which is getting with carbon, and then cobalt oxide and lithium ion is got segregated. So directly lithium is not there, lithium ion is segregated, and that's why it is a non-hazardous. It remains lithium ion directly as a metal is a hazardous. So your coin cells which you use in your motherboard cells, or maybe the coin cells which you use in many of your small power torch applications somewhere, or maybe in some cameras, there are the lithium ion metal cells are used. They are hazardous in nature, but if it is the lithium ion, which is not a metal, so then it becomes a non-hazardous in the nature, and directly if it is not taking the part. So that's why ions are changing the electrode. So we have in the application, we have the electrodes, positive electrodes and the negative electrodes. So ions are changing its direction from this side during the charging and discharging process. So that's why it is not exhausted. The ions are not exhausted. It is only changing the directions. So that's why we have the higher of life cycle of the lithium ion cells, and the physical properties of the cell remain static. It doesn't change very fast, and those all things are in the favor of a higher life cycles of the lithium ion cells that we have. So what is the most evolving area into the lithium ion cell is, so if you are into the interested towards the chemistry of the cells. So cell chemistry is very evolving area as of now. New cell chemistries are in demand, and with the help of chemical knowledge, and if you are from the material science background or from the physical science background, or having the knowledge on the chemicals. So then, and you are interested to go into the research, the battery scientist thing, that if you are interested to go, so then cell chemistry is one of the very big domain for you where you can look at, and the thermal management. So thermal management is there for the battery pack designers. So because what happens that if we don't have a good thermal management, because cells are very sensitive, and if we are not able to do the manage the cells thermally, we are losing the most of the capacities of the pack in the heat energy. And secondly, not only losing the pack's capacity, but also it is playing with the life of the cell, because almost once the temperature gets increased, so the chemical reaction rate increases, that leads to the bleeding of current from the cell. And once the bleeding of current will happen, so again the temperature will rise, and there is a certain of a temperature, like NMC chemistry if I'm talking about, so around 210 or 250 is the temperature range. So certainly these temperature ranges are achieved very fast if the cell is the thermal properties are not getting managed, and cell can go bad. Even NMC chemistries can burst like a bomb. So for the safety purpose and for the proper utilizations of the energy and the life of the cell, the thermal management is a very budding domain where one can look at. So this is a two rapidly evolving lithium ion cell area where one should look at, apart from the other things. And these are some of the global lithium ion cell suppliers. And it is, if you can see, there is a no Indian company as of now. We are having the cell supplies either from China, Korea, Taiwan, and Japanese side. And there are 1-2 companies there from the North American side, but majority we are having from this zone only. And regarding the chemistries, if I'm talking about, so there are the lots of chemistries. If you are working in this domain, or maybe planning to go, if you have done some research, so you must be seeing the variety of the cells, like LFP cells or NMC cells, the lithium polymer cells, the pouch-based cells. So there are the various of the cells you must have hearing of. but exactly what is the chemistry that is being used as of now for majority of our applications, and what it is planned to do, where industry is moving. That's what is a very important thing to know, because if you are looking at into this domain, the trend is very necessary to get captured. So 2018, 2-3 years back, so 5 years back, if I can see. So it is the NMC and the LFP chemistry. So it started with the NMC chemistry itself. So this is the nickel, manganese, and cobalt is used as the cathode. But there is a high thought process in the people, in industry people, that cobalt is a toxic material and we should try to move from the cobalt. So then this iron phosphate based chemistry was evolved. So LFP was the iron phosphate based chemistry, but the iron phosphate has the lower of a specific energy. We can have the higher power, but energy storage is lower into this LFP chemistry, and there was a higher leakage of a current was there in the LFP. So that's why it started, and it started mainly by some companies in the China, but it didn't pick up. The majority of the world didn't pick up the LFP chemistry. So NMC remain a standard, and in majority of applications, the NMC chemistry is getting used. LFP is still been there, and it is getting pushed by the lots of Chinese companies, because they have developed, they have invested towards the chemistry development, and they have kept working on it. So prismatic cells, if you see, majority of the prismatic cells, you will find it is the LFP chemistry based and of a higher of a capacities. But there is a higher of a rejection rates, and the failure is there in the LFP. So industry doesn't support much. The standard industry doesn't support much the LFP chemistry. So it is expected, and it is getting used majorly the NMC and the NCA chemistry, the manganese cobalt or the nickel cobalt aluminum based chemistries, which is used by Tesla. But NCA has a little lower of the cycle life. So that's why NMC is common for everyone. And as an anode, the graphite material is used. In the LFP, we have the lower of a voltage also, like for the voltage, if I'm talking about. So higher is the voltage, the less number of cells that we will require in the battery packs. So if it is the LFP chemistry, it was the 3.2 volt was the voltage for the LFP. But if I'm talking about the NMC, so it is the 3.7 volts that we have, starting from 3.67 to 3.7 volts that we have in the NMC chemistry. And that's why this is the more used chemistry as of now for many of applications, not only for electric vehicles, but for the portable applications, the power banks and all. Solar applications, you might find the LFP based chemistry is still getting used, because there we don't require the high pressure on the cells, or accelerations are not there. There is a continuous use and continuous discharge pattern is there. So that's why LFP could be used in the solar applications. But for e-vehicles, for power bank, all these applications, we have the NMC chemistry. And it is expected now the sulfur based means sulfur-based cathode, and then the silicon-based anode. So if we are able to achieve this silicon-based anode, then we have the drastic increment into this voltage. So right now you are having the nominal output from your cells 3.7 volt, and think of that if you have the nominal output 5 volt, then how less number of cells that you will have to use in the battery pack, and how much the energy capacity that you are able to increase in that small amount of space. So this is the trend towards the uses of the cathodes and the anodes in the design of the cells. And the comparisons, if I have to see, so there are the chemistries that is common is the NCA, NMC, manganese oxide, LMO. Then we have the LTO cells. You must have heard of LTO cells are majorly used in many of applications for the space applications. And then we have the LFP chemistry. So NMC, the majority of the competition is there between the NMC, the LFP chemistry. So if you can see, it is the cost-wise, it is comparable, but specific energy it has higher, whereas the specific energy in the LFP is quite low. So that's the one reason for the for discarding of it. Performance is higher of the NMC chemistry compared to the LFP, In the safety, it is higher. The LFP is higher because the iron phosphate is used. And so there is a no toxic element, the cobalt is not present, and there is a low of a specific energy in it is. So that's why it can't explode. The LFP chemistry generally leaks out, like even if the thermal runaway condition occurs, so it leaks out, it doesn't explode. Whereas the NMC chemistry will explode just like a bomb. So that's what the thing is. The specific power we can have higher in the LFP chemistry. So these are the comparison factors. Whereas the LTO cells specifically, if I'm looking out, so it is a very high. It is in the safety. It is a very high, and that's why it is being used more in the space applications and in the defense applications. The LTO cells are getting used. In some of the four-wheeler applications, the LTO are going to be popular, but it is still in the test phase. Whereas NCA is having the higher of the specific energy, cost is also lower, and it is little less towards the safety side, because its thermal runaway temperature is very low. It's around 150 degrees centigrade. The thermal runaway temperature is, and so cell gets high heated very fast. So that's why the very specific thermal management process needs to be there in the NCA chemistry if you are using. But we can have the high power and high energy into this. So automotive applications are using these NCA chemistries due to this nature, because the power can be dragged more, and where we require the more and more of an acceleration, like in electric cars, that sometime we require. So then this NCA chemistry is a suitable one. So it is the cells that so it is the cells and the smaller battery packs that we have talked about, and the chemistries. But the lithium ion doesn't end over here. So it's starting from the cell design to the modules design to the complete battery pack for your bigger applications. So modules are there for the smaller, like 36 volt module or a 48 volt module. So these are the smaller battery packs. But once we are talking about the battery packs for the cars or for electric buses, then and maybe the storage applications for whom the power storage applications, then multiple such battery modules are got connected, and then they are communicating to each other for the provisions of the power. So then the battery pack for the bigger applications, there the opportunities are there, good. And here we have the BMS also. So for with each and every module, we have the BMS. It is a data-driven battery that we call. And then every data is got connected to a data point of the BMS, through which the application main interface remains connected. So there is a huge opportunity into the communication of these battery packs also, because it is a data-driven, and then the electronics around it. And then it comes the gigawatt capacities or higher capacities battery racks actually. So where lots of such battery packs are there for the provision the power to the complete secondary power sources, as a secondary power source to the bigger factories or maybe the larger establishments. So starting from the smaller battery pack design, we can go up to the gigawatt capacity storage or the higher kWh capacity storage of the battery packs, and there are the lots of opportunities that we have. So these all the things that we have talked about the cell, but and the battery packs. But if I give you a battery pack in your hand, or maybe a cell in your hand, will you be able to tell me that what is the SOC of this, and how much health it has lost, how much it has decayed, what is the DOD of this battery cell, or maybe the DOD of this battery pack, how much years it is going to last? Like if the battery pack I have given you after usage of a 1 year, can you tell me, just taking it in your hand, that how many days now it is going to last? So this thing is not possible just by holding the battery pack in your hand or cell in your hand, because it is a dumb thing. So it is just like an elephant. So if the spatially challenged people are there, and if they touch the elephant, so to some of them it will seem to a wall. To if it touches the tail of that elephant, so it is a rope. There is a story behind this, so I'm not going to tell you the story as of now, but you must have heard of in your times. So it is this To some of them, it will feel like a fan. To some of them, it is spear. So it is the same thing towards the battery also. So then what is the thing that tell me about the battery? It is the BMS. So the job, and so for the lithium ion cells, there is a huge requirement of the BMS is also there. And that's what the electronics part is with the batteries. And there is the market or in the automotive side or the energy storage side, the aerospace side, everywhere there is a demand for the BMS is there, starting from the channel counts from up to the, even the single cell we have the, it is the battery management system. BMS is the battery management system I'm talking about. So even you are using a single cell in your, maybe you have a battery powered LED bulb in your home that is having a single cell, that also have the battery management system, and up to the gigawatt size battery storage. Everywhere there is a requirement of the management system into this. So what does this BMS or the battery management system do? So its primary job is to sense and sense the voltage of the cells, individual cells, and the complete battery pack, and give the protection to your battery pack so that it won't go into any of the thermal runaway states. So the first and the foremost requirement is from the BMS that the cells should not go into a thermal runaway state. So that's what the protection that you provide. Thereafter, once the cells are there in the connected in the battery pack, so what are the things that it establishes? So it does the capacity estimations of that, what is the charge left, what is the SOC level of the cell, how much the cell is decayed, because with every charge and discharge cycle, with every loss of a cycle life of the cell, some part of the chemistry of the cell is decayed. So overall, the health is decreasing over a time period. And once this decayed up to around 20%, like once we have taken the cell, assume that it is the 100% of the health of the cell is, though it doesn't remain, even the cell remains in the storage. So there is some loss to the life of the cell happens. So assume that once we have taken the cell in the battery pack, the health was 100%, and 20% of the loss of health happens maybe in 3 years of the operation. Then once this 20% of the loss of the health is done, it means 80% of the SOH is left for the cell, then it would be discarded from the electric vehicle application, and then it opens the opportunity for the secondary battery market. Like the same cell could be used in the another applications where we don't have the accelerating behaviors. So SOH measurements it does. Thereafter the thermal management it has to do. So this is the protection side, and then the balancing, that's the also bigger factor is. So we have the cells, and this is the physical thing. So we have the multiple of cells connected in the battery pack. And once we are charging and discharging, though while we are making the battery packs, we take the same quality of cell. But because this is the physical thing, maybe over a usage of a time period, maybe this is getting charged up to maybe 80% in 1 hour. And the next of the cell is getting charged only 75%. And in just in that 1 hour, and another cell is got charged up to 85% in that 1 hour. So then once we are using the battery pack, so we assume that we have given the charge up to 85%, but actually it is the weakest link that works on, and our battery pack will be used only up to the capacity of the 75%. The 5% of this cell will remain left, and the 10% of this cell will remain left. It won't be used. So this is the job of the BMS, to distribute the charge evenly among the cells so that every cell should remain same charge, so that we can use the maximum of the capacity of each of the cell and can make our battery pack more efficient. So these all things are the job, the responsibility of the BMS is. And for this, the firmwares and the hardware is there in your BMS. If you are designing the battery packs, or maybe looking at the battery packs, if you have opened any of the battery pack, you must have seen the electronics circuit is there, and that is the battery management system. And apart from that, there is a CAN bus requirement is there. So this CAN bus does the communication between the vehicle and the battery pack. So to provide the diagnostic informations, like if the battery pack is going to be discharged, what is the charge level you have, what is the life that you are expecting. So all these informations that needs to be communicated to the vehicle powertrain, and all these things have been given by the BMS to the CAN communication network. So this is the requirement for the BMS, and there this potential is. And the innovation, if we are looking towards the electric vehicle, so then we have the two things, the new type of electrodes, which I have talked to you, that new type of cell chemistries are in demand. So if you are towards the battery scientist side, so then you should be looking towards the development of some new electrodes and electrolyte materials with a higher of the energy and the power densities. And then the solid state lithium ion batteries, that is also in the practice, that solid electrolytes will be used in that case, because that will have the higher of energy storage compared to the volatility of the ions. As so this is one innovation approach. And the next of innovation approach towards the lithium ion, where it is more towards the battery pack design side. So previous I have discussed about the cell design side, and here towards the battery pack design side. So now it is the time where we are mixing the lithium ion with the fuel cells and the capacitors, the capacitor, super capacitors you must have heard of. So we are now using the electric vehicles for the electric bus applications and the electric car applications. So so super capacitors are also getting integrated with the lithium ions, and some companies like Ashok Leyland has done some work towards this with ABB. What they have done, because in electric bus, what it is that we have bus stations, and there is a gap of around say 1 or 2 kilometers there between each of the stations. So if we are providing some mechanism in the bus that that mechanism is getting charged in very few amount of times. Normally what happens that lithium ion takes time to get charged, whereas supercapacitors get charged and discharged very fast. So if we are having the supercapacitors in the bus, and the bus, once the bus comes on the station and maybe it stops for a minute, and so within that minute, if I'm able to charge that supercapacitor up to a level so that it can move the bus to the next 2 kilometers, and then again on the next bus station, I can again charge the supercapacitor. So then it would be the quite lower the cost of battery pack that we are able to do, because supercapacitors are lower in cost and it can be charged and discharged fastly. So the quantity that we also require lesser of the battery. So bus will be having the lower of the weight respective to the battery pack and can move faster. So this is the integrations that is happening, and lots of work is going of the integrations of the lithium ions with the fuel cells and the supercapacitors. And then there is a regenerative braking system, though in two-wheeler systems it is not possible, and if there are some companies who is providing, but it is actually of no use, because in two-wheelers we are not able to generate that much force so that we can generate the power back. But yes, in four-wheeler applications there is a lot of happening for the regenerative braking. And then we have the secondary batteries also, like we have the primary battery which is driving our powertrain, secondary battery for running our other loads of the vehicle, like AC application, light applications, headlights and all the things. So by the regenerative braking, those light applications could be, or the AC applications could be run. So this is a one thing in the innovation is happening towards the powertrain side for the upliftment of the battery pack. So these are the innovations happening. And if you are looking at towards the opportunities in the lithium ion, so what are those opportunities? So either you will be doing your own startup if you are doing your entrepreneurship. So you will be doing your own startups, or maybe you are starting something, you are doing something and you want to enhance the capacity of your company. So there's entrepreneurship side, and thereafter there is the job is there. So if you are a student and looking for jobs, so there is a lots of job opportunities are there, and then the battery scientist side. So if it is the entrepreneurship and startup, so first and foremost thing comes in our mind is the battery pack assembly business. But it is not only limited to this. We can even with a very small, even like battery pack assembly, maybe it is taking you 15-20 lakhs to start, and you don't have that much capacity, you don't want to invest that much. You can start with a very small things of providing the batteries on rent. You are taking the batteries, integrating the technology with it, and providing the batteries on rent to the fleet operators. That would be the very smaller business, and you can earn on recurring income that you can have on the each of the charge and the charge of the battery. And people are doing it. So that battery on the rent is a very good business that you can have. Fleet operation that you can, you can tie up with the EV fleet operators and provide the services to them. The charging stations that you can establish. The sales and service of the battery packs is there. So right now what is happening that the battery pack manufacturers are providing the services to their retailers and to the customers. And there is a no intelligent electronics or IoT is being used much. But if you are developing some solution where you can remotely diagnose the battery packs, so and then you can remotely diagnose the battery pack and can give the instruction to the user to do these things. And because it is the electronics that is majorly at a fault most of the times, if it is been done good, the BMS is done good. So majorly the electronics that is at a fault, so that could be remotely diagnosed. So in the worst of the scenarios, the battery has to be brought back to the factory, and most of the things can be done at the user end. So the battery analytics solution or the sale and service remotely diagnostic services. So in this, you don't have to establish a factory for the battery pack assembly. You have the interest towards the electronics or maybe towards the software side, and you can develop some kind of a solution for this, and can provide with your battery packs. Then consulting services you can provide into this. Testing services, like once the battery pack is designed and it is going for the ICAT verification, before that you can provide the testing services so that it won't be rejected at the ICAT labs. The manpower supports and the BMS, that is also a very budding field in the domain. So these are the different of the opportunities that you have as an entrepreneur to start with, without much of the investments, and swiftly you can investing much of time also. Apart from this, if you are looking towards the battery scientist side, so then the chemistries that you can look at, advancement into the chemistries, provisions of the safety provisions. So these are the domains which you can look at, and can make your specialization into the chemistries, and can excel in the battery scientist domain. Then how to increase the SOC and SOH and the life cycle of the existing chemistries. And then the BMS. So there are lots of algorithms are there in the BMS and the BTMS. So you can develop some algorithms and estimations for the BMS firmware. So these are the things towards the battery scientist side. As a battery system engineer, if you are looking the job, so it is not only the mechanical engineer or electronics engineer have the opportunity, but even I say that even you are a commerce graduate, you have the good opportunity in the lithium ion, because you can do good in the business side of the lithium ions. So whether you are a hardware engineer, you can work towards the application development engineer, like the company is involved into the battery diagnostics design or maybe the BMS design. So there the application development is required. So application developer, you have the proficiencies. Thereafter, the validation you can do as a battery scientist engineer. If you are a mechanical from the mechanical background, so the mechanical design of the battery packs, that is a very unnecessary thing. That for which of the application and for which of the chemistry of the cell, what should be the exact mechanical designs. So that's what right now, if you will be taking the battery pack, so you go to any of the box designers and you make the battery pack box from there. Either you procure them or you order them to make it. But exactly there is a science behind it, and that's why the mechanical engineers are required for this purpose, for the designing of it. The electrical engineers are there who will be taking care of all the process of the designing of the battery pack, and then the electronics engineers have the requirement for the design of electronics and the BMS side. If you are in a production, so process engineering, material engineering, like whatever the cell that is coming for the production, so that needs to be validated. So material engineer is there and production supervisors are there. As a test and quality assurance engineer, you have to test about the different, so these are the responsibilities for the test and quality assurance engineers for the complete profile testing, life cycle testing of this battery pack that is getting manufactured. So batch sampling, through the batch sampling. Then the thermal management things, the testing for the thermal management, the stress testing, and the packaging, final packaging of the cells, and which is going to be transported, because there is a special policy for the transport of the cell is also there. So the packaging should be done as per the transport policy and as per the ITA standards and maybe the road transport standards, or if it is an export cell, so or the battery pack, so it is as per the policy. So that's what needs to be considered, and this has to be done by the test and quality assurance engineer. Apart from this, so these are the primary domains, and secondary, then we can have the battery analytics engineer, so who can be providing the solutions for the for the behavior understanding of the battery pack. Right now, we are using the EVs, and what the most thing that we are lacking is that we are not much aware about the behaviors of the user towards the uses of the electric vehicle and the battery packs. Once you will have the full data of the user, and that will take time to come because it is still EV is in a nascent stage. So once you will have the complete behavior of the user towards your battery pack, then you can design more efficient things. So battery analytics is a one budding domain where you can know, where you can analyze and develop the models for the battery pack designs based on the user behavior. Then BMS engineer, there is where there is a requirement of a knowledge on embedded systems and IoT and communications and all. Then sale and service and maintenance things that you can start. Remote diagnostic supports I was talked about. Then ecosystem comes consultant. So whether you are establishing the battery assembly business or maybe the charging business, so the ecosystem consultants are there. Then the fleet consultants. So if one is going to start a fleet, so then the fleet operators consultancy or policy consultancy, that's what the opportunities that we have. And then the secondary battery market. So this is again going to be very flourishing in next 2 to 3 years. Right now we are having the primary cells, but think of a scenarios, and right now it is happening that lots of cells are getting discarded from the electric vehicle applications. Where do all those batteries will go? So because they have the capacity left, only 20% of the capacities that has been decayed from them, still 80% that we can use. So we can use it in the another of the applications like in inverter applications or power bank applications or somewhere. So the secondary battery market that's what is the biggest budding thing that we have recently. So if we have the take the knowledge into this, or if you are going into this lithium-ion battery domain, so what are the knowledge that is expected from you is knowledge towards the complete cell technology, the knowledge on the charging and discharging profiles, the chemistry selections as per your application requirement, means for your particular application, how you select the chemistry for your particular cell and how you can distinguish that which one cell is used for you. And then the calculations for your battery pack, the sorting of the cells, the knowledge of the tools and the machines for the process, and then the mechanical and the physical knowledge on the thermal management, like the person who is doing the thermal management for you. So you must be also knowing that whether the method and the technology he has used for the thermal management is right for the particular application battery pack or not. Then the simulations that you should be knowing about, the transportation standards that you should be knowing about, so that your battery pack won't get stuck in the transport once you are sending it from outside. And then what are the IoT and AI behaviors that you can apply in your battery packs, so that remotely you can diagnose and cut the maintenance cost drastically. So these are the knowledge that is expected. There is just one fun thing that I will be discussing you here. Lots of people that talk to us that related to the with this battery pack establishment. So they ask that it is the soldering thing. So they are more remain concerned towards the spot welding kind of a thing, or the practical the spot welding. But spot welding is a very small domain of it. The knowledge needs to be there, and that is actually been done at the helper level. But if you are at the entrepreneur side, or if you are towards the engineering side, so you have to take care of a larger perspective of the cells, where the lots of estimations knowledge, the simulations knowledge, and the theoretical knowledge also, because every day some new concepts come into the lithium-ion domain. So lots of those conceptual knowledge required into this. If you are looking for the job, so expectations, if you see, so for the variety of the profiles we have, and this is a global data that I'm sharing to you, and in context of India also, there is a huge a prospect is there. So starting engineer to the design engineer, you can see that lots of battery scientists have the highest of the prospects, that is towards. But whether it is the test engineer you are having, so around this is the annual that you can expect, and then application development, you are having this much amount of expectations of 130,000 of dollars, US dollars per year that you can expect. This is the global standards and electronics. So with each of the domain that you can see that that there is a huge potential we have. So whether it is the entrepreneurship that you are taking up to, or it is the job that you are up to in the lithium mine, so you have this potential. So what we have to learn into this domain is about the lithium-ion chemistries, the characteristics, the charging profiles, the cell aging behaviors. So when the cell is aging, what is the effect of it and how we can recover those things and how we can estimate. So based on the aging of the cell, what are the effects of this aging on the charging, on the SOC, on the SOH, and on the DOD of the cell, thereafter the life cycle of the cell, the internal resistance of the cell. So how these all things are getting affected. So all these things that needs to be estimated, because these all are the estimation things. The physically you will never be able to get all these things. So these estimations are required. Then the battery pack calculation is a very, very necessary thing that you should know about. Then the mechanical designs, thermal designs, how to calculate the effective cost of your battery pack. Then the BMS thing that you should look at, and the safety standards, calculations of the SOC and SOH, how we can make our lithium-ion battery pack smart. And then if you are from the electronics side, so then you can have this knowledge towards the IoT and AI thing. So these all are the domains of requirement, domains of the knowledge which is being expected from you. And until and unless you don't have this complete understanding of the thing, you will never be able to excel into this domain. So this was the thing related to the opportunities, where the market trend is going on, and where you should look at in which of the hole that you need to fix about for you, and you have to sit in that hole and exactly so that you can do lots of things in this domain. So this was towards the discussions of this side. And if you are one more thing that so we are having the, as I have told you in the very beginning, that we are having the training program on the lithium and the a powertrain, and then we have the training program on the BMS designs also. Just a few minutes I will take more for the letting you know that what we are providing in the lithium ion domain. So this is a 6-week program as of now we are providing in the lithium ion sector, where it is a live online session that we are providing, and we have the weekly sessions. So 4 days in a week the sessions are there, and in all this is 100% practical oriented sessions where we talk you about the estimations, the simulations, and the firmware behaviors, like for the calculations of the properties of the cells to the firmware and the hardware. So that is the remotely accessible hardware we have, and that's what we are using. And then it is the 1-year support that we do. So after the training, once you start the thing in this domain, so then what are the supports that you require? Like you are starting your entrepreneurship journey, and you are starting a battery pack assembly business maybe. So then you require some support in some technology selection, or maybe you are stuck somewhere in designing of the battery pack. So various kind of supports that you require. So you can always come back to us and we provide the support for you. So after the training, that 1-year support that remains. And as far as the contents is concerned, so we are covering you all the aspects for the lithium ion, which is there, for starting from the chemistries, behaviors, which I have discussed, to the estimations of all the capacities, designing of the battery pack, the internal resistances, the aging behaviors, the policies related to the transportations and storage of the packs, and then the functional safety standards, how you can get certification of your battery pack from the ICAT, and life cycle, secondary life applications, and then how we can provide the smart battery electronics. And then it is the if you are making your battery assembly business, so then you should have the knowledge on the selections of the tools. What are the tools that you require for the establishment of your plant, and what is the right business opportunity that you have. So that's what also we used to discuss in this session for the tools and the technology selections. And then BMS and BTMS is right now the bonus program that we are giving along with this, where we used to discuss you about the selections of the right BMS for your particular applications, how we can estimate the SOC, SOH of the BMS for your particular battery pack, how we can do the field programmable BMS. So everything, the selections and the topologies related to the BMS that we do. And then we discuss about the thermal management. So the thermal management, what are the different thermal management methods are, what is the, how do we calculate the exact thermal property for the cells, how much the heat loss that is going to happen due to the thermal runaway conditions. And then for a particular thermal condition, what should be the material and how we should use the which one thermal management method should we use. So all these things are covered through the modeling. So MATLAB modeling, so all these things are getting covered. And then we also cover about the electrical and the mechanical design of your battery packs. So what are the considerations that you should have? What should be the model of the mechanical design of the battery pack? So these all things are covered. So after completion of this course, you get a complete understanding of whether you are going to start your lithium assembly business, lithium ion battery pack assembly business, or if you are going for the job. So for both of the perspective in the lithium domain, we are providing you this information. So this is a 6-week program, and this is completely hand-holding support that we used to provide. 52 weeks of complete 1 year of support that we provide. We provide you. So once this is delivered through the live session, and once live session is completed, so then you have this videos. So the videos are uploaded into this. We have the LMS. Into the LMS, the videos are uploaded. The supporting notes are got uploaded, and then a continuous evaluation is being done so that we can track your progress. And then at the end, we provide you the certification for this. So this is for the battery packs. And then if you are looking towards the BMS side, so then we have the embedded systems program also. So if you are interested for the BMS designs and looking for the smart electronics design, so then we have the embedded systems and IoT program, which is a 3-month-long program. And here we cover all the aspects of the microcontrollers, the design of the peripherals for the applications, and then the provisions of the IoT and cloud. So the battery diagnostic business or anything that if you want to develop. So all these things are covered into this, the embedded systems program. And there is the project is there. So there is a mandatory project. So at the outcome of this embedded system program, you can develop your own BMS also. So this is the opportunity that we have. And this is again a 3-month-long program. And the practicals are through the completely online remote access mode hardwares. We provide the hardwares to you. So these are the hardwares that has been provided. So these are the complete set of peripherals that we used to provide, and you develop your things based on this. So lots of people have done from all of the parts of the world. It is not only the India that we are using to serve. So this is some of the testimonials of the students who have worked on this. These are some of the scenes from the live sessions. So all the hardware tools and the software tools, everything is being provided from our side, and you develop it. So these are the 2 programs that is there for the lithium-ion battery pack side and for the BMS side. If you are if you are having interest towards the powertrain development, like in the parts of the North America, if you are interested in for the jobs or maybe for the doing the business, so there you require the knowledge on the powertrain also. So as North American and Canadian region requires you the knowledge on the powertrain knowledge also. So we have the complete powertrain designing program also. This is again a 6-week program, and where we start with the vehicle design side to the EV ecosystem. Then we go to the vehicle design dynamics for the 2-wheelers and 4-wheelers, and how do we calculate the various of the behaviors and the parameters for the vehicle, like what is the aerodynamic design should have, what is the torque your motor or the vehicle. Thereafter, what are the calculations for the powertrain. And then for the 2-wheelers and 3-wheelers, we do the complete design of the vehicle, and in the figure that I have shown you. And then we come to the calculations and the simulations for each and every component, your motor, brake, the throttle, each and everything. Then the thermal design considerations, And also we give you some knowledge there about the lithium ion batteries there also, so that you can take the knowledge, the benefit of the lithium ions into the powertrain side. And then in the last, we come to the smart dashboard systems, where the data that is coming from the various parts of the vehicle, how we can display and take it in a meaningful manner, how we can implement the IoT, like IoT based powertrain, which I have shown you. So how we can take it to the IoT level, what are the global standards and certifications that you require for working in the different part of the world towards the powertrain, and then the certifications and assessments are there. So this is again a 6-week program, and all similar kind of supports that we used to provide through our LMS. So this is the thing that I wanted to discuss right now. Now I'm ready to take the questions from your side. So that would be lovely to take the questions from your side. So many of you must have inquired about the programs previously. So right now the new batch on this lithium ion is going to start from this 10th of August. So if you are interested for the upliftments of your skills, upskilling yourself, so you can take the lithium ion program from the 10th of August. The embedded systems and lithium ion is going to start from 10th of August and 10th and 11th of August. And the EV powertrain program is going to start after 15th of August. So you can plan accordingly if you have the requirements and interested to do things in this. So our here I'm sharing you the form link. So if you are interested, you can fill up this form. Maybe our team will get in touch with you, and you have our WhatsApp numbers and the social channel links. So definitely you can always contact us for any of your requirement. So thank you for being with us for so much amount of time. I will be happy if you are putting some questions to me. If you are working in this domain, facing some issues, or if you are looking in this domain and are not able to decide that where I should look at, maybe I can discuss with you. That would be beneficial. Okay, so there is a question from Mr. Grease that how to start career in consulting as a mechanical engineering student. So Mr. Grease, if you have the knowledge towards there are two things are there. So either you can provide the design support for the battery packs, the design support for the battery packs for the casings and all the things. And secondly, for the vehicle. So with the knowledge on the designing and the designing softwares, that is a must required, like the CAD softwares are there. So there you can start with. But before that, you should have the knowledge on this, either the powertrain side, if you are going for the electric vehicle, a design side, or if you are going towards the battery casings design consultancy. So there you should have the knowledge on the behaviors of the cell. So those two things, if you have the knowledge and have the knowledge of the CAD tools, you can start your consultancy business or the design service business into the vehicle design or maybe the battery pack design business. That would be very much required. There are very few people in this domain who are working, and manufacturers are looking for the people who can develop good battery casings or the vehicle frames. Is the answer satisfying you, or anything more you want to ask in this? Welcome. Any more questions? Don't hesitate to ask. It is not a gradings for the questions are being done. Okay, so there is one question is how to start lithium-ion battery maintenance station. So maintenance station for the maintenance station, so you have to either do two things. Either if you are looking at a small site, so then you can start a small a service station and can take the battery packs from the retailers or the people who are using the vehicle and do the maintenance of it, like the there are the lots of electronics issues that remain. If it is the cell issues, then it is a very rare chance because then requires a very high investment for the cell maintenance to do. So there the manufacturers are doing it. But if it is at a small level, if you want to do, so majorly towards the BMS side or the electronic side you can do, or towards the mechanical side you can do. But there is a less opportunity as of now in this to do it as an individual basis. So what I would suggest you that do two things. Either you develop something towards the remote diagnosis side and contact with the lithium ion manufacturers to to integrate your solution, your diagnostic solution into their battery packs, and remotely you can diagnose the cells, provide the data to the manufacturers, and maybe provide the solution also for the uh, for the this thing for the maintenance of the cells or the battery packs to the user directly through your application, so through your remote diagnosis applications. So this is a one thing that you can do. Or otherwise, what you can do that you establish your own service station where you require the electronics equipments and the some cell maintenance equipments like the sorting equipments are required, and thereafter the disassembly of the packs that needs to be required. So all these kind of things that you require at your station, and can talk to the manufacturer that whatever the discarded battery packs come to them, you can take those battery packs and can evaluate it and evaluate about the different of the parameters, the behaviors of the cell, like the life based on the life expectancy, the SOC level, SOH level. Based on this, you can disassemble the battery pack, can group the cells as per their different of the parameters, and then can again form the secondary battery packs and can give it to the again the manufacturer if it is to be used in the electric vehicle, or maybe to the other manufacturers then for the other applications. So the two things that you can do. So better would be to come in the contact with the manufacturers and do an integrated thing. So if it is the battery diagnostic thing that you will be starting here, you will have the less of investment and the better of usage of the technology that you will be able to do. So asset light business that it will remain. But if you are starting a completely a secondary battery maintenance business, so then it would become a little asset heavy business compared to this, but that also has a huge opportunity. Is that okay, or something more you would like to know into this? So what you do as of now, Mr. Said is? Yeah, within 10 to 15 lakhs, you can start with an asset light business. The remote diagnostic solutions you can develop and can integrate it with the battery packs of the manufacturer. So asset light business, you can start with 10, 15 lakhs. And that would be a good sum to start with. You should have the investment of the knowledge towards the IoT side of it, and the IoT side and the electronics side majorly, and the behaviors of the cell. Welcome. Okay. So time is nearing. So I would request that if you have, you can just ask me. Otherwise, we are available on our WhatsApp. So our WhatsApp number is, so you can always reach to us on our WhatsApp, or this is our email ID. You all have perhaps the emails keep coming to you. So you can always send your email to us if you have any kind of queries or the requirements for this purpose. And I would request you one more thing. So if you have liked this session, so you can always review us on Google. So I'm sending you the Google review link. So you can put a review over there if you have liked the things, what are the services that we're providing to you. And it is nice to stay in touch with you all. You just be excel in this domain and grab the opportunity which is available right now to you. Shall we close, or anything else that you want to ask? Okay, so thank you for being connected. I'm closing the session. Enjoy your time ahead, and all the best for future of your things.